Hi, everybody. Welcome to this platform. This is Sichamba Jacob. And we've got a question right here. It's under speed time graph. All right. So the first question here, they're saying find the acceleration. So we just ran out of space. It was supposed to be acceleration in the first 5 seconds. So this is the acceleration we are looking for. So one quick thing, there is another acceleration here. So keep this in your mind that you're looking for the acceleration in the first 5 seconds. So acceleration, the formula looks like this. Acceleration is equal to final velocity minus initial velocity over time. So this is the formula you need. If you want, you can use the formula for finding gradient. It also works, okay? So here, when we look at this, first 5 seconds, it's up to here. So we can say data, we gather our data. So what is our V? Our V is the final velocity right over here. Can you see it started accelerating from here all the way to here. So our V is a 10, okay? So we always get the velocity this side. This is where velocity is, and down here it's time. So now when you check where it stopped, it was here. Now you go to your left-hand side. That's where the velocity you're looking for is. And then U stands for initial velocity, where it started from. It started from zero, while T is the time, which is 5 seconds. So just plug in this information. It will be equal to 10 minus 0 over 5, and this will be a 10 over 5, which is equal to 2 meters per second squared. This is our acceleration in the first 5 seconds. Okay. So the next question here, which is question B, they're saying we find the value of V, which is right over here. So the value of V, we find it when they've given us acceleration between 10 and 15. So they've given us the acceleration between 10 and 15 where it was going like this. That's acceleration, and they've said it's what? It's 2 meters per second. So here, now look at what we're going to do. We'll forget about this. Forget about this. The same formula is what we need. The same formula for acceleration. But this time around, the V and U as well as the T will be different. Okay, so let's try to check this. V, it started accelerating right over from here and it ended accelerating right here. So where it ended there, when you check, there it's a V, which is a final velocity. Where it started here, it's 10. So 10, and the time difference, time between 10 and 15. So just say 15 minus 10, which will give us a 5. So from here, we can say equal to, what is our A? Of course, A must be there. The A, it's 2 meters per second. So instead of just saying equal to, where there is A, we write a 2, which is equal to V minus the U is a 10 over the T, which is a 5. So we can solve for V. So this will give us a 10 is equal to V minus 10. We just cross multiply. There's a 1 here. 5 times 2, it's a 10. 1 times V minus 10, it's V minus 10. We say 10 plus 10 is equal to V. We group the like terms. So the value of V will be equal to 20 meters per second. This is velocity, so it's supposed to be meters per second. Okay, so let's check out the last question, which is average speed for the whole journey from right here up to somewhere right there. So how do we get to find the average speed? So without wasting our time, speed, of course, supposed to be distance over time. So let me show you. So we can say speed is equal to distance over time. That's a speed. Okay? Now, when you look at this, do you have distance? We haven't been given distance. So we can now calculate distance. We're going to separate. I want you to understand something. So let me show you this shape. So there is a shape that looks like this. I want you to see. So this is a shape. Here it's a 0, here it's a 10, and where here it's a 10. So going up from here to here, it's 10. So now you're going to say distance 1, which is the distance from here all the way to here. That will be equal to 1 over 2 A plus B times H. So this is the formula for finding distance of a trapezium. This is a trapezium right over here. So whenever you want to find distance or area of a trapezium, we use the formula which is right here. It's the formula for area of a trapezium. But under this topic, we use it to find distance. So we can say 1 over 2, our A is a 10 plus our B, it's actually a 5. Now I want to say something. B is a 5 and H is a 10. So now look at what I've just done here. My A will be a distance from here to here. That's my A, which is 10. My B will be a distance from right here. Look at this. We've got this line and this line. So the distance from here to here, it's a 5. Because it's starting from 5 all the way to 10. So 10 minus 5, it's a 5. That's where the 5 is coming from. While for the height, it's from here to here. That's 10. So 2 into 2, 1. Into 10, it's a 5, which is equal to 15 times 5. 10 plus 5, it's a 15. You multiply these, you're getting a 75. So that's distance 1. Distance 1 is equal to 75 meters. Okay? So we now find distance 2. Okay? I'm separating these shapes. So you can either do this, find area of the triangle, area of the rectangle, area of this shape, which is a trapezium. But in my case, I've just said I'll find area of a trapezium, and then I come and find area of this other trapezium. So let me go to the next trapezium. So the next trapezium, things will change a little bit. So it's like this. We've got this side, it goes like that, and then this side like that. So from here, this is 10, and this is 15. While from here to here, it's a 20. Remember, we found the value of V to be equal to 20. So it's a 20. While here, it's a 10. Okay? So we need to know from here to here, it's a 5. That is from here to here, it's a 5. While from here to here, it's a 20. Here to here, it's a 10. Okay? From 0 to here, it's a 10, which is a 10 right here. So we're going to say distance 2 is equal to 1 over 2 A plus B H. The same formula, because this is a trapezium. Now, things will change. These two parallel lines, one of them will be our A, the other one will be our B. So from here to here, it's our A, and that's a 20. Okay, plus. From here to here, it's a 10. Now the distance, the height will be the distance from here to here, which is a 5. So we can do our board mass. We start with what is inside the brackets. That's a 30 and a 5 here. So 5 into 2 into itself, it's a 1. Into 30, it's a 15. So I've got 15 times a 5, which will give us a 75 meters. So distance 2 is also a 75. Okay. So now we can start our conclusion. So here we are simply going to say total distance, this stands for total distance, is equal to 75 plus 75. You add these two distances, the distance of this and the distance of that, we're getting a 150 meters. So now we can say speed is equal to distance, which is the total distance, 150 over the time. From here to here, it's a 15. And when we simplify here, 15 into 15, it's a 1. Into 150, it's a 10. So the average speed is equal to 10 meters per second. Thank you so much for watching. Please remember to leave a comment in the comment section. And if you want to join our online classes, you can get in touch with us on this number right here. You WhatsApp. We will guide you on how you can join our online classes. Please subscribe to this YouTube channel. Thank you and bye-bye.